Now we are going to review solving linear equations. This is something that's been going on since pre-algebra, beginning and intermediate algebra, so we should be good with this. Number one, all these guys are linear, which means we should have one answer, unless we have a weird situation pop up. And so we're just trying to get x by itself. Now, in my mind, I like to move my term so that my x term has a positive coefficient. So if I look at number one, I'll subtract the x. So this guy has a positive coefficient here of 2x. Now at the same time that I'm moving the x, oftentimes I like to go ahead and move the constant as well. So we'll move the constant to the other side. So subtract 98. So your x terms reduce on the left side, constant terms reduce on the right. I have 2x is equal to negative 98 and 14. It's a negative 84. And then I finish solving this and getting x by itself by dividing both sides by its coefficient. So 2, and that means that x is equal to negative 42. And number two, a little bit less complicated than the first one. We just need to move the 23 to the other side. So these guys reduce. I have 3x is equal to 96. So if 3x's are 96, divide by 3, and you find out that x is 32. It's all about getting the variable by itself. What you do to one side, you do to the other side. And so that comes from using the addition and the multiplication properties of equality. 3 is just like number 2. It's just different numbers. So I need to subtract the 31 first. These guys reduce. 5x is equal to 45. Divide both sides by the coefficient of x. Remember, you do not divide by x itself, just the coefficient. And so we find that x is equal to 9. And again, it shouldn't be that bad for us to check this out. If I plug 9 in here, 5 times 9 is 45. 45 plus 31 is 76. Number 4, there are two ways that we have for working this. Just depends on what you want to do. Here, I could divide by 2 first, or I could distribute. It doesn't really matter. Oh, just so maybe you can see something that's a little bit different. If I divide both sides by 2, here the 2's reduce. I end up with x plus 11, and on the other side I have 27. Subtracting 11 from both sides yields the solution that x is equal to 16. And again, you can easily plug this in. 16 plus 11 is 27. 27 times 2 would give you 54. All right, now let's change this up just a little bit. These guys were nice, good review problems for you. Let's go to what we all love, fractions, right? Now, to get rid of a coefficient that's a fraction, just multiply times the reciprocal. So I'm going to write this guy a little bit larger for us so that we can see this. We can see what's going on here. You could divide both sides by 12 over 5, but that just means a little more work for you. If you just go ahead and multiply both sides times the reciprocal, I think you'll see the magic. See, when I multiply times the reciprocal, you see that the 5's reduce, the 12's reduce, and all I have left is x. On the right side, it's just a matter of can you reduce this. Now, you can multiply, get really large numbers, but why not reduce beforehand? 5 goes into both of these, so 5 goes in here once, and here 3 times. 28 and 12 have a common factor of 4. 4 goes in here 7 times, and in here 3 times. So what you're left with, 7 times 1 in the numerator, 3 times 3 in the denominator, So x is 7 over 9. Even though it's fractions, it's not something for us to freak out about. Number 6. Number 6 has some work that needs to be done on the right side. So when I rewrite this, I have x plus 13 equals. And you see here that we have like terms, so 2x minus x is just x. So we have x plus 13 equals x minus 3. You need to get your variables together, so if I subtract x from both sides, watch what happens. When I do this, the x's reduce. They reduce on both sides. I end up with 13 is equal to negative 3. Now what we have here is clearly a contradiction. When we solve equations, we assume that the original equation is true, unless we reach a contradiction somewhere along the lines. We do this a lot of times in proving certain theorems or certain statements in math. You assume something is true, and if you reach a contradiction, then you know the original statement was not true. So sometimes we call that a proof by contradiction. So there's no x here. They legitimately went away. You end up with something that is not true. So for this false statement, what that means to us is that we actually have no solution. Now, a lot of times students will write no solution when they just don't know how to do the problem. I know, I laugh too, LOL. You only have a no solution statement whenever the variables completely go away and you have a false statement. In number 7 is a lot like number 1. Get your x's to one side. I would move my x's to the right because that gives me a positive coefficient here, 4x. But I'd also move my 65 to the left, so I'm going to subtract 65. Those guys reduce. 15 minus 65 is negative 50. So now when I finish solving for x, divide both sides by 4. Now 4 does not go into 50 evenly, but I don't think I really care. I prefer to have improper fractions as opposed to mixed numbers or decimals as an answer. So I can reduce this by a common factor of 2, and I end up with negative 25 halves. Now the next problem is a doozy. That's old people talk for. It's difficult. We have a lot of fractions here, but what we have seen before, and we saw even more clearly when we had rational equations, we clear the denominators. Get everybody to have the same denominator or multiply everybody times the same denominator, and you're going to be good. So the common denominator here is 16. So I'm going to multiply everything here times 16. I'm going to rewrite this for you. So this is 16 over 1 times 3/4 x minus, so 16 over 1 times 3 plus 16 over 1 times 1/8 x. And you do the same thing to both sides. 16 over 1 times 1/2 x plus 16 over 1 times 11/16. If you really do have a common denominator, then all of these denominators are going to reduce away. Check this out. 4 goes into 16 4 times, so you end up with just 12x. 16 times 3 is 48. 8 goes into 16 twice. So you see on the left side of the equation, you don't have any denominators. You use the multiplication property of equality to multiply both sides times 16, and we're just simplifying now. So 2 goes into 16 8 times, so we have 8x here, just 8 times 1x. 16 is reduced to give you a 1, so that's plus 11. Now, if we go ahead and combine like terms, we combine like terms, is going to give us 14x minus 48 equals 8x plus 11. Now again, I want to move my x's so that I have a positive coefficient, so I'm going to move 8x to the left side. When I do, I'm going to end up with 6x. Move the 48 to the right side, that's going to become a positive 48 over here. So 48 and 11 is 59. And then divided by 6. And I end up with this very wonderful answer, 59 over 6. It does not reduce, so it's kind of sad, but it is what it is.